All right, guys, I'll try to make this as quick as I can, but I want to go through lesson 12.8 and have you learn about it now, give you all the information now, so then tomorrow we can just practice it. So again, I'll try to go really quickly. There is a lot of information, a lot of different types of graphs, so if you are taking notes on this, then you may need to pause the video, take a note, pause, take a note. Also, if you'd like to take some notes, I can definitely give you access to the slides. Just let me know and I'd be happy to do that. So we're going to go through in 12.8 several different types of graphs. Now it's going to really come down to knowing when to use a certain graph in a certain situation. So I'm going to go through these different types and try to give you a hint saying, all right, hey, when you see this type of situation, here's the type of graph you'd want to use. But ultimately, the types of questions you'll get from this is that it will give you a situation, you'll choose the type of graph you need to use. So I've got to run through a bunch of different types of graphs. Again, I'll try to go quickly. Pictographs obviously shows us data using pictures. A lot of times a pictograph, you'd want to be comparing the number of several things, and it would want to be an obvious picture, like fruit, maybe different things like Gatorade, pop, and water. An obvious picture for each one of those. So that's the key. If you're comparing things, a number of things, and it'd be easily pictured, a pictograph would be a way to go. Dot plot shows the number of times each value occurs. If you have several repeating values, like in this case, you can see there are a bunch of 9s, 7s, 2s. If you want to show which one has the most, a dot plot would be an easy way to do that. And notice that here, we're comparing values. With a pictograph, we'd be comparing something more tangible. Next, a bar graph shows data using specific categories. We talked a little bit about the difference between a histogram and a bar graph. A bar graph, we are comparing January, February, March, April, and those 4 people. We're looking at January, February, March, April, and comparing those 4 people. A histogram, we're looking at ranges and just saying, okay, in this range of numbers, here's how many we have. Histogram isn't necessarily comparing things, but a bar graph, anytime we're looking at comparing data, that would be our go-to. A circle graph shows data as parts of a whole. So anytime they say, okay, we have 20 people, 5 of them did this, 7 of them did this, and 8 of them did that, and we want to compare those 3 parts, those 3 things people did, a circle graph would be our way to go, comparing parts of a whole. Those are the first 4 types of graphs. So again, if you were taking notes and want to pause it right here, here's a really good place to see all 4. The next couple types of graphs is a histogram. We're already familiar with this, but it shows frequencies of data values in intervals of the same size. So we look at those intervals that are, again, the same size, and it shows how many fall, the frequency, how many fall in each one. We also have a stem and leaf plot. We've seen this before. It was a little confusing the first time that we saw it, but we have seen it before. The big thing here is that it orders numerical data and then also shows how it is distributed. So it puts it, again, in order from smallest to largest, but then shows which one has the most. We can quickly see they're the most in the 10, 12, 13, 16. In that column right there has the most. Next, a box and whisker plot shows the variability of data using quartiles. So it can show us how spread out it is. We know that each one of these chunks is 25% of the data. So it can show us, oh, look, there's a lot of the data in this chunk. There's not a whole lot in this chunk right there. So it can show us how and where the data is spread. Next, the dot plot. Did I double up on the dot plot? Yes, I did. Skip. Lastly, scatter plot. When we are looking at a relationship between 2 data sets, a scatter plot is very useful. We're looking at, okay, as we have more of these, do we also have more of these? We can see in this case, it looks like it is trending in a positive direction. So if we're trying to show that there is a relationship between 2 things, that's the key, is a relationship between the 2. One other one that's important to note, and we'll see it on the next slide, is a line graph that looks like this. A line graph will be useful when we are looking at something over time. That's going to be the key, is we are looking at something over time. Yeah, that's a line graph right there. So this is my last slide. That did go pretty quick. Again, if you needed to take more notes or listen to it again, or listen to it again, you're more than welcome to do that. But I'm trying to be quick because you're very familiar with a lot of these. The last piece that you're going to see on this is misleading graphs. Why are these different things misleading? Is something that's going to ask about. It's going to give you a lot of different types of graphs. If we look at this first one, this is something that you see even in commercials a lot of times, is it does not scale evenly. You can see from this first chunk is 8, then this is just 1, then this is just 1. That's not even. If they wanted to go to 10, they don't have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but they at least have to go 2, 4, 6, 8, 10, or 3, 6, 9, 12. They have to at least somewhat evenly. They can't just jump to 8 and then go by ones. Maybe you saw already in this one. Did I give 2 examples of the same thing? Yes, I did. This one jumps to 8 as well. Yeah, they're the exact same thing. Oopsies. If we were to look at this one, look at how the bars get thicker as they get higher. Might not be obviously super misleading, but when the bars get thicker like this, it does make it look like this is way higher than this first one, when in reality, it's really not that much higher at all. So this graph is misleading because the bars are not all the same width. So that's just 2 examples. Sorry, don't ignore this one. Those are just a couple examples, but part of what you're going to look at here is it's going to give you a couple different types of graphs. And it's going to say, okay, what's wrong with this? Something that's common is in a histogram. Maybe they'll have this be from 0 to 1. Then maybe this one will be, and this bar will maybe look like this. And then maybe this one will be from 2 to 5. Will look like that, and I didn't mean to make it way wider, but pretend they're the same. Then maybe this one will be from 6 to 7, and then this one will be like from 8 to 20. That's very misleading. Those intervals are not the same. That's a common one the textbook likes to use. So I won't go through every situation of a misleading graph, but those are just a few. Some things to be careful of are things not being scaled the same, not the same thickness, or these intervals not being the same. Things like that would be what you need to watch out for. So, all right, hopefully that was quick. Hopefully that made sense. I know I talked really fast, but now you've got some time to practice this on your homework. Thanks for listening.